Hello, dear my friends. Tonight we will be looking at applications of a Fourier transform. The Fourier transform is a very strong mathematical tool that we find in different areas in the real world. So let's first look at the key contributors, and one of them is Leonard Euler in 17th century. And then we also had Jean-Baptiste Joseph Fourier, 17th century to 18th century, and then this guy called Peter Gustav Dirichlet, who is the one who stated the conditions. He defined the conditions for a Fourier series to converge, and that was very, very powerful. There are other guys like Henry Bézique and Norbert Wiener. So let's look at the first application of a Fourier transform. In signal processing, we analyze both periodic and the non-periodic nature of the audio signals, and this helps us to be able to decompose them into their frequency form, and then we are able to iron out what is not in the frequency that is required, and then we retain what is actually in the frequency that is required. For example, imagine when you are interested in oh, and then there comes in something like so. A Fourier transform helps you to remove those that are having maybe high frequency, and then you retain with those ones with those signals with lower frequency. So image processing also, we look at edge detection, image reconstruction, and filtering in the frequency domain. First of all, these images come in space domain in terms of two dimensions like x, y, and then we use a Fourier transform to take them to the frequency domain, and then we'll be able to do some iron out, reconstruct at some edges that are not seen, and then that image actually is going to come out very clearly, and that is the power of a Fourier transform. Then filtering, so designing of filters for non-periodic signals, the same. So in design, of course, we want to remove some signals of particular frequencies and then maintain some other frequencies. So that mathematics behind is the Fourier transform. So in electrical engineering, we do have communication systems. So in modulation and demodulation, digital communication, for example, in a technique of modulation called orthogonal frequency division multiplexing, is widely used in modulation in modern communication systems, particularly in wireless and broadband technologies. So this OFDM is working on the powerful tool of the Fourier transform. So in power electronics, in power systems, analyzing transient signals and designing filters for non-periodic disturbances, and also filtering out some undesired harmonics, maintaining maybe fundamental component of the harmonics, then they are the powerful tool that you run to is the Fourier transform. So in imaging, we want to reconstruct images from raw data using Fourier transform, that is in machines like magnetic resonance imaging, in hospitals, computed tomography, also we do the same. Reconstructing those cross-sectional images from X-ray data, we use a Fourier transform. So data compression, for example, MP3 compression, we use Fourier transform for audio compression. The same thing with video compression. For example, MPEG. So for you to produce an MPEG, then you need to do a Fourier transform. So all of these are incorporated within those softwares that do actually this work. So those softwares are working with the knowledge of Fourier transform at their background. In the computer graphics, animation, creating smooth animations by decomposing motion into harmonic components, that is a Fourier transform. Texture synthesis, generating realistic textures for 3D models. In geophysics, seismic data analysis, whereby we analyze earthquake movements. So those earth movements result into seismic waves. And studying these waves enable us to understand the Earth's interior structure. Then tidal analysis, these tides that always appear in oceans, we need to know their patterns, and then we'll be able to predict their behavior by taking them from the space or time domain and bringing them to the frequency domain. So the key takeaways in this discussion, we have seen that a Fourier series is actually ideal for periodic signals and applications in audio processing, also vibration analysis and image compression, whereas a Fourier transform is more general and versatile tool and is applicable to both periodic and non-periodic signals. Its applications in modern communication systems, medical imaging, and transient signal analysis.